Hello! I've dug out the vocoder and put it on my desk, and it's probably going to sit there for the next few videos. I just want to get back into the sort of process of making videos for the vocoder. I'm speaking into two microphones here, one which is going into my phone, which is shooting this, and one which is going into the microphone input, which is this board over here. And that's being fed into the bar graph so that you can see the level of that microphone. But that wasn't really what this video was about. It was about something different. So what I'm going to do now is take my headset off and switch on my voice recorder, my Zoom H1N, and start recording native audio for the next section of this video. Let's start the camera recording. I'm now going to start a recording on the voice recorder. There it goes, it's Zoom 0006. Oh no, you probably can't hear anything because I have to bring up the microphone level there. Now this board over on the right hand side is the sort of tone generator which I fed into this other pot, so I'll just turn that up. Now it's noise at the moment, but let's put it on the oscillator. There it is. Let's turn up the oscillator. Now that's very low frequency. Let's turn that down a bit because that's going to overwhelm my microphone sound. So you've got pitch here. Bring up the other oscillator. And there we've got two oscillators. Oh, well, they're an octave apart. Yeah, so that's unison. That's a fifth interval. And that's sounds a bit like bagpipes, doesn't it? Because I think they use the pentatonic scale. But anyway, that's an octave apart. But what I wanted to do was listen to the noise output. Now I can do that by turning these oscillators off. Actually, I'll need to lower the volume levels of the oscillators, not just reduce the pitch, and turn up the noise generator. So this is a digital white noise generator using these two chips here. That's the noise generator, but even when that volume is down at 0, noise is being fed through to this voltage controlled amplifier, and it's being triggered by whatever is generated in all these knobs. So it could be oscillators, it could be noise, it could be the external input, which is on a connector here, which is not connected at the moment. But let's move this over to there. And that noise is being fed through the VCA, but the volume level is very low at the moment. Now if I turn up one of these oscillators at minimum frequency, well actually no, let's turn it up at maximum frequency. And that tone generator is now generating a tone which has lifted the volume level of the VCA, which is passing noise through to the final output, the recorder, I suppose, in this instance. Now if I turn down the frequency of the oscillator, because the oscillator is now running so slowly, you can hear it as a pulsating input to this VCA, so you can hear the level of the noise going up and down about 5 Hertz, I suppose, something like that. And that's part of the circuitry called the voiced and unvoiced. This is quite boomy and bassy. I'll turn it down so it's a bit more trebly. The voiced unvoiced detector. And what that does, if I make sounds like s, no, not s, ch, all of the high frequency sounds, but with no tone. So if I say s, then there's tone in there. But if I say s, then it's just noise. And when it detects that it's all high frequency, it will actually switch an analog switch. Now that's that chip socket down there. Can you see it? Yeah, you can just see it over there. The chip's not fitted yet because there's no power supply for it. So that's one of the things I'll be doing in a subsequent video. Which is just a very simple Zener diode and resistor dropper So I'll be fitting that for that. It's a CD4016 quad bilateral analog switch. And whenever you make a sibilant sound, the idea of this part of the circuitry is if I go s, then it will briefly interrupt the sound that's coming in through this external socket and replace it with noise. And so the noise level that's being fed in must be at the same general level as everything else. And therefore it's got a VCA so that it matches the burst of noise to approximately the same volume as what was coming through previously, which might be some music, for example. Okay, let's stop this shot here while I think about what to say in the next one. So I think for the next shot I will go back to my headset and just point out a few things here. So 4 boards here, the input amplifier, the LED bar graph meter thing, a final output mixer amplifier. So this pot is doing the input amplifier, so that's the microphone. This pot is actually doing that yellow croc clip, so that's what I'm taking off this tone generator and noise generator board. And that is what's called the internal excitation board. Now further up, if I tilt this down, I've got my voice recorder here. So this is what I'm using to record WAV files, which will be inserted into the final mix. I've got my power supply and distribution board down here. This is a 5 volt to 12012 board. You can't see it because it's hidden behind the distribution board. My 5 volts is coming actually from this supercapacitor, which is being charged by that power supply at the back there. I just thought I'd put a supercapacitor in here. Well, partly because it was on my desk and partly because I thought it would sort of keep the noise levels down, although of course all this 12 or 12 generation is switch mode, so there is going to be some switch mode generated noise. Well, let's just stop there actually for this video, because one of the main things I wanted to do was remind myself how this voice recorder works and how I dub the voice recorder sound over the top of the headset sound. So I'll cut the video there and then I'll come back with the next video with perhaps a little bit more detail and maybe some soldering on this board here. But for this one, cheerio.